In this lecture, we are going to discuss about the beta decay. Beta decay is a type of radioactive decay in which an unstable parent nuclei is split into daughter nuclei and its release high energetic electrons. So the highly energetic released electrons are known as beta particle. Now question here is that, dear student, the way how beta decay basically occur. The answer is quite simple. The beta decay occur in unstable nuclei where a neutron is basically converted into a proton. So the conversion of neutron into a proton basically cause the emission of highly energetic charged electrons, and these high energetic moving electrons are basically called beta particles. So now let us define beta decay. Beta decay is a radioactive decay. Radioactive decay in which unstable daughter nuclei, parent nuclei, unstable parent nuclei are atom converted into stable daughter nuclei, release daughter nuclei are daughter atom releasing high energetic electron, high energetic electron called beta particles. So the student, in beta decay basically the radioactive unstable parent nuclei is converted into a stable daughter nuclei, and during the conversion of unstable parent nuclei into daughter nuclei, there occur a release of an energetic electron or release of a moving electron, and that moving electron is called beta particle, and the process is called beta decay. So now, how beta decay occurs? Dear student, in beta decay, basically, there is in a nucleus, as you know that in nucleus there are protons and neutrons. So in some atoms, number of neutrons are more than the number of protons. And when the number of neutrons are more than number of protons, then such types of nuclei are unstable, and these unstable, and these atoms are also called unstable atoms, and nuclei of such atoms are called unstable nuclei. So these unstable nuclei prefer to stay as stable. So in that situation, the neutron inside the nuclei of an atom is converted. Neutron, suppose this is a neutron which is present inside the nucleus, it is converted, or it's turned into, let me change its color, it's turned into proton, turn into protons. So when the neutron turn into proton, in that situation they release highly energetic electrons, and these electrons are very fast moving and they have very high energy. These electrons are known as beta particles. So if I conclude beta decay, in beta decay, basically in unstable nuclei of an atom, the neutron is converted into proton. And during the conversion of neutron into proton, a new daughter nuclei which is stable is formed, and along with that high energetic electrons are released. These electrons are moving electrons, and these moving electrons are called beta particles. Now, students, let us write a nuclear reaction for beta decay. Consider we have an element X. Since you know that atomic number of an atom is represented by Z, and atomic number is basically a number of proton or electron in an atom, or electrons in atom. Whereas the mass number or atomic mass, which is represented by A, is number of total number of protons and neutrons. So the element of periodic, every element in a periodic table are represented on the basis of atomic number and atomic weight. Atomic number is Z, and atomic weight or atomic mass of an element is represented by A, and it is above the element. So suppose that this is an element and we want to do the beta decay of this element. So this element which will need to be unstable, and it will be converted into new element. Suppose it is represented by Y. So initially the X is a parent atom, and the nuclei of this parent atom is unstable because of extra neutron on it in it, or more amount of neutron in it. So this parent nuclei will be converted into stable daughter nuclei Y, and during the beta decay, this parent atom, basically the neutron of the parent atom, is converted into proton. So as you know that atomic number is basically representing a number of proton or electrons. So when the neutron is converted into suppose we can write it, the neutron, suppose this is a neutron. Neutron is basically during the beta decay, neutron N is turned into proton. So in nucleus, one neutron is decreases, whereas in nucleus one proton is increased. So this means that atomic number, as you know, that it is a number of proton or electron. So atomic number Z will be increased by one proton. So it will become Z plus 1. And since you know that the atomic mass is basically represent number of proton plus number of neutron, since the neutron is converted into proton, but the amount of total amount of proton and neutron is, if we add, they are same as the total number of proton or neutron of X atom. So this means that atomic mass of daughter nuclei or daughter atom will be same as the atomic mass of the parent atom or nuclei, and then there will be a release of high energetic electrons along with it. These energetic electrons are moving electrons, and they have too much energy, and these energetic electrons are known as beta particles. So this is basically a nuclear reaction for beta decay. So, dear student, if I conclude the beta decay, in beta decay, basically we have a nucleus, and nucleus has a proton and neutrons, and the atom, if having more amount of neutron than protons, then such types of atoms are unstable. These atoms basically will convert or turn a neutron um, into uh, into protons, and during the conversion of neutron into proton, they release highly energetic radioactive particles, and these radioactive particles are known as beta particles, and the process is known as beta decay. Now, dear student, let us just perform, or let us have some examples of beta decay, that how beta decay occur in different types of elements of periodic tables. Consider an example of carbon C614. Consider the beta decay in C14, carbon 14 isotope. Okay, since you know that the atomic number is Z is basically represent a number of proton or electron, so it the atomic number of carbon will be 6, and whereas the atomic mass is basically it is a number of proton and as well as plus neutron. So as you know that atomic mass of carbon is 6. This means that we know number of proton, they are 6. Then if we minus 16 from 6, then we get 10. This means that number of neutron in carbon 14 is 10. So now, dear student, in beta decay, in beta decay The neutron is basically converted into proton. So this means that atomic number Z will be increased by 1 and it will be 7. So new element which will be formed during the beta decay for carbon 14 will have an atomic number of 7, and atomic number, as you know, atomic mass during the beta decay remains same, so the atomic mass of new element will be 14. So now if we check a periodic table that which element has an atomic number of 17, so we can easily find that it is nitrogen, having an atomic number of uh, 7. And with this, they will also release high energetic electrons or beta particles. So in this way, basically, dear student, beta decay will occur in carbon 14 isotope. Now, dear student, let us solve some problem for beta decays. Consider that we have an unknown element. And that element performed a beta decay, and during the beta decay a daughter nuclei of sulfur 32 is formed, and along with that it releases a beta particle. So now what is that element which basically causes a beta decay? Since you know that in beta decay neutron N is converted protons into protons. So this means that the atomic number atomic number Z is increased by +1. So the parent atom will have atomic number of 15, which is basically changed into atom having an atomic number of 16. Whereas the atomic mass in beta decay remains same, so the sulfur has atomic mass of 32, so the parent atom will also have atomic mass of 32. Now check the periodic table that which element has an atomic number 15. So by checking the element having an atomic number 15, we can find that it is phosphorus, which is basically faces a beta decay, and phosphorus converted into a sulfur and release a beta into sulfur and release a beta particle. So in this way, we basically find the unknown element which basically causes a beta decay. Now consider another problem. Before going to problems, dear student, please keep in mind that in beta decay, these are 2 points you need to memorize: mass number, which is basically A, remain unchanged. And number 2, in beta decay, atomic number Z increase by +1. So in this way, basically, you can easily find the elements which are basically going through a beta decay. Consider an example. Consider that we have iodine having atomic number 53 and atomic weight 131 is going through a beta decay. So simply we, as you know, that the mass number in beta decay remains same. So the new daughter element formed will have a mass number 131. It will remain same. However, in the rule for beta decay, the atomic number increases by 1. So the daughter element will have an atomic number of 54. So then we can go to periodic table and we can check that what is an element having an atomic number 54. And when we check, we can see that it is xenon having an atomic number of 54. So basically iodine is converted into a xenon during a beta decay. So this is a simple rule we can memorize for beta decay, and on the basis of that basically we can solve the problem for beta decay. Just memorize that mass number in beta decay does not change, it remains same, whereas the atomic number during a beta decay basically increases by 1. Now consider another example of beta decay in which we need to find that what is an element, parent element, which is converted into daughter nuclei of cobalt 27, 52 plus beta particle. Since you know about the rule of beta decay, the mass number remain unchanged, and whereas atomic number increased by 1. So now, in case of finding a parent nuclei, the atomic number basically, it will basically decrease by 1. It will be -1. So where atomic number of parent nuclei will be -1, and whereas the mass number will remain same. Okay, so it will be 54. So the parent atom have mass number 54 and atomic number basically it is decreases, it is 26. So now we need to check an element in a periodic table, which element have an atomic number of 26, and we can find very easily that it is iron. Basically iron is going through a beta decay, and during a beta decay it is converted into a daughter nuclei of a cobalt and as well as beta particle. So different, please keep in mind that beta decay is sometimes called beta minus decay. It is quite closer to a positron decay, and in positron decay basically positron decay in positron decay basically a proton is uh, proton is converted into neutron. So if I conclude beta decay is a process in which a parent nuclei is converted into a stable daughter nuclei, and during the conversion it releases highly energetic electrons or beta particles. Beta decay only happens in those nuclei which have extra amount or which have more neutrons in it, and the more amount of neutron basically causes the instability of a parent nuclei, which result into formation of a daughter nuclei. So this is all about the beta decay. So thank you for watching this lecture.